Welcome to Summarize Science. We constantly hear that AI is getting incredibly good at math, but a new study shows that even the most powerful models still struggle when the problems get tough enough. Researchers created a new benchmark called AMO-Bench, designed to be extremely challenging for even the best AI. As you can see in this chart, while top models score nearly 100% on existing benchmarks like Math 500, their accuracy plummets on this new test. So, why did they need a new test in the first place? For one, the best AIs are starting to max out their scores on older tests, a problem known as performance saturation, which makes it hard to measure new improvements. Additionally, many existing benchmarks use problems from past competitions, raising concerns that the AIs might have simply memorized the answers from the data they were trained on. To solve this, AMO-Bench was built from the ground up with 50 completely original problems crafted by human math experts. Each problem was rigorously reviewed to ensure it was at least as difficult as those found in the International Mathematical Olympiad. They even used other AIs in a preliminary screening to filter out any questions that weren't challenging enough. The results were staggering. This chart shows the performance of 26 leading AI models on the AMO-Bench. The best performing model, called GPT-5 Thinking High, only achieved a 52.4% accuracy. Most other models, including many well-known names, scored below 40%, revealing a significant gap in their reasoning abilities. This is a massive drop compared to the near-perfect scores seen on older tests, proving that these models find it incredibly difficult to solve novel, complex problems. The struggle is real, and it shows the limits of current AI technology. The researchers also found a fascinating trend. The better a model performed, the more thinking it had to do. This graph plots performance against the average amount of text, or tokens, the AI generated to reach an answer. There's a clear pattern where higher scores require vastly more computational effort, suggesting harder problems demand more elaborate reasoning steps. But here is where it gets really interesting. There's a huge glimmer of hope for these AIs. Researchers looked at K, which measures the probability of getting a correct answer within K attempts. While getting it right on the first try is hard, this chart shows that top-tier models have over a 70% chance of finding the correct answer within 32 tries. This means the ability to solve the problem is often there. The AI just struggles to consistently identify the correct reasoning path on its first attempt. So, let's recap the important points. First, researchers created a new, incredibly difficult math test called AMO-Bench because older tests were becoming too easy and potentially compromised. Second, even the world's most advanced AIs performed poorly, with the best model only getting about half the questions right. And finally, despite the low scores, these AIs show hidden potential, as they can often find the right solution if given multiple attempts. This suggests future AI development will need to focus not just on knowledge, but on making reasoning more reliable, which is a significant hurdle that still needs to be overcome.